Yeah, today's lectures will be centered on pesticide toxicity. So we are going to define what is pesticide toxicity. We are also going to talk about how we evaluate it. So what is the pesticide toxicity? The toxicity of an insecticide, for example, is usually expressed in terms of LD50 or lethal dose. We do this to any pesticide. So the dose per unit weight lethal to 50% of the population of the organism is known as the LD50. In other words, it is the dosage which can kill about 50% of the population of test animals if we are administering that pesticide to a population of animals. So the LD50, which is a measurement of toxicity, is expressed in milligrams per kilogram or mg or milligram per kg of body weight. The LC50, on the other hand, is the lethal concentration. This is the concentration of the insecticide in the external media that will kill half of the test population. With LD50, the test animal has to get the pesticide inside its body. LT50, this is the time required to kill 50% of test population at a certain dose or concentration. But in most cases, we use LD50 just to get an idea of how toxic a substance is or how toxic the pesticide is. Now there are certain testing procedures which are used. Okay, let me admit somebody. Okay. Now there are testing procedures which have to be followed if we are going to determine the LD50. Normally we use some animals or some test organisms. We have to establish the dose-response relationship in order to determine toxicity. So it's in the form of a graph where we plot the concentration versus the percentage of animals which are killed. So the animals for testing are divided into random groups, usually 6. One group is used as a control. This could be treated with a solvent only or a blank. The other groups are treated with doses, usually in a geometric progression, if you like. These are like treatments. Actually, these are treatments. For example, 1, 2, 4, and 8 milligram per kg body weight. Those animals in the control group, if you want, they receive a 0 mg per kg body weight. They are not going to be given the pesticide. After 24 or 48 hours, the response is measured and expressed as a percentage of the total group. The response usually measured is death. Now there's a formula which is usually used. This is known as the Abbott formula, which was introduced a long time ago in 1925 for correcting mortalities during this kind of investigation. You have x minus y divided by x times 100. This is the corrected percent mortality, where x is the percent of survival in the untreated controls and y is the percent of survival in the treated insects, for example. What sort of data analysis which is going to give you the results which you need? The percent mortality is converted to what are known as probits. Normally we take the data in the form of percentage, but we have to convert it to what are known as probits. The dosage, which is usually in milligrams per kg body weight, has to be converted to logs, to a logarithm. The above are plotted in a graph, and a log dosage probit line is drawn. So your graph, on the x-axis, you have got the log of your concentration, and on the y-axis you have the probit values which are obtained from the percentage mortality. Now the LD50 can be estimated from actually you get a regression line. So you can estimate the LD50 from the regression line. And the sample size of test animals, usually you want about 120 test animals. Well, there are some people who think that conducting these trials to get data on pesticides is being cruel to animals. So there are some groups of people who do not like these experiments to be conducted. However, we can do some tests, for example, with the insects. So how do we administer the pesticide? There is what is known as topical application. Here in this case, the insecticide is dissolved in what is known as acetone. It's a chemical, and then using a micro syringe you can administer a known volume of the pesticide to the insect. Probably you have a series of concentrations which you have to administer. Now this method is tedious job. It requires too much time. and some insects, due to size, are difficult to treat. If you were doing a research project on these things, probably it could be a difficult project to conduct. The other method where I said the topical application of the pesticide to the insects, the other method is to inject the pesticide to the insect. So the insecticide is also dissolved in, it can be dissolved in peanut oil, propylene glycol, or acetone, and injected in the body cavity of the insect. Now, it may be difficult to find the solvent that is not toxic to the insect and that will dissolve sufficient pesticide. So sometimes you find that the solvent itself may kill the insect, and you cannot tell the activity. You can't differentiate the effects of the solvent versus the effects of the pesticide. Some insects may not be injected because of size and behavior, so it may be difficult to administer as well the pesticide. There is also another method known as the dipping method. Remember, we are trying to evaluate the pesticides so that probably we have an idea of how toxic they are. So the dipping method, we take the insects using forceps to hold them, and you actually insert or dip the insect in the desired insecticide concentration. After treatment, the insects are placed into a container and we assess the effects of the insecticide, probably by counting the dead insects, the live insects, so that we assess what is known as mortality. The other one is known as the contact method, where we expose the insects to the residual of the insecticide. So it's a residual exposure method. How this is done: you take the pesticide, dissolve it in acetone, and put it into a glass jar, which you can rotate so that you allow the solution to coat the walls of the jar. So you want to spread your insecticide on the sides of the jar. Acetone will evaporate, leaving the pesticide on the walls of the jar. You can vary the doses, and probably you put your insects inside. There is also a precision sprayer which can be used to apply the pesticide using petri dishes containing leaves with probably with aphids. So the contact method. There is also a fumigant method. Probably you are now exposing the insects to fumes of the insecticides. This method is suitable for stored products, there are these weevils which can damage our maize in storage. We can evaluate the toxicity using a fumigant, which we can introduce into the insects. So a fumigant is introduced in a sealed container with insects. Mortality is recorded at different intervals. You come in at different times, counting the number of dead insects, live insects, and you get your data. There is also the feeding method. This is used to test insecticide against larvae. Larvae are placed individually in a container and starved for a few hours. You make them hungry so that when you introduce your poisoned stuff, they will have no alternative except to eat what is available. So they are fed individually using a small leaf disc with pesticide. Then mortality counts are made after 24 hours. You know, you count the dead larva, the larva which has survived, and you take your data. That was for insects, which can be done easily. And of course, it has its own challenges. When you are trying to find how toxic is if you want to find the toxicity of the pesticide. The other method, you can use the higher animals. This is when you can get problems, with the animal rights and so forth. You can use rats, mice, rabbits, dogs, monkeys. So, in fact, the number of available animals for this purpose could be limiting. So you may not be likely to do these studies because of various problems. As I have said, there are animal rights groups. There's also the issue of ethics. Are you going to obtain your data without killing animals? You know, these are the issues. So here is somebody in a laboratory trying to evaluate toxicity. You can see the person is wearing protective clothing so that she is not affected or is not affected in the process. Now let us look at the levels of toxicity. There's what we call acute toxicity or acute toxicity tests. In this case of acute toxicity, animals are fed the pesticide or a force feed using tube. Mortality is then recorded after 24 hours. The median lethal dose is the LD50. Or you can use an albino rabbit which of mass 2 to 3 kgs. It is shaved on the stomach area and the back. The pesticide is applied from outside. It's a contact pesticide, which is applied on the shaved area as a paste and secured with a cotton gauze. After 24 hours, mortality is recorded and referred to as dermal LD50, because the poison is supposed to go via the skin. That's why it is dermal LD50. Then of course it can actually kill some of the animals. There's also what is known as acute inhalation toxicity. It is obtained by exposing the animals to the pesticide fumes in a chamber for 4 hours. After, let's say, 14 days, the lethal concentration, or LC50, is obtained. So in order to get this data, some animals have to be killed. There's also what we call, what we were talking about is acute toxicity, something which happens immediately. So there's something known as subacute toxicity and chronic toxicity. Subacute toxicity may take a bit of time, not hours. Probably in order to get the effects, you may need up to 90 days. With the chronic tests, you may need a period of over 2 years. These are long-term effects, but they need to be assessed. But these effects, which are on tissues and organ function, may reveal carcinogenicity, teratogenicity, and mutagenicity. These are cancer-related things. Probably you may not have any pesticide levels which you are administering. Now this graph explains what can happen to a group of animals if you subject them to a pesticide. Within a group of animals, there are some animals, depending on their genetic makeup, they can easily die using very low concentrations. But the bulk, or most of the animals, could die when they receive the medium dose. Probably these are the dosages which we eventually recommend for pest control. At very high dosages, you may find some individuals surviving. These have got genes for resistance. This is the population which eventually give rise to pesticide resistance. Now, if you were conducting an experiment where you are varying the dosages, you are increasing them from 0 to a certain milligram per kg body weight, and on the response you have the percentage of death of the animals. You get that kind of a graph. At first, nothing seems to be happening at low dosages. I mean, we have got the 0 there in the control, written nowhere. There is no death. But as you increase the concentration, you may reach what is known as the threshold level. Then you reach a plateau. 50% of the animals which are going to die will take us to the LD50 as indicated in that graph. And this is how the LD50 is determined after carrying out the evaluations or trials or experiments. Here on this slide, we wanted to simply explain the levels of toxicity. What we measure within a short time, it could be within days, is what we call acute toxicity. It has immediate effects after exposure to the pesticide. Then there's something which we call subchronic toxicity. We could have repeated exposures to the pesticide over a bit of a long time. It could be months or weeks, not days. So that is subchronic. Then the other exposure, which is low dosage but repeated exposure over the years. This can affect workers who deal with pesticides. They are always exposed to these pesticides over a long period. We get chronic toxicity. Subchronic, this is a medium dose, but it is repeated over a number of weeks or months. But acute toxicity is high dose. Single exposure can produce serious consequences within a short time. So these are the degrees or classifications of toxicity. But nevertheless, they are harmful to the organism. So LD50 values actually give us an indication of how toxic the pesticide is. The higher the LD50, the less acutely toxic is the pesticide. If you get low numbers, that's a very, very dangerous product. And the precautions should be taken seriously. A generalized dose response curve has 3 distinct regions. Which I need to go back to this graph. So this graph has got 3 important areas. The 0 area where nothing is happening, representing the control. Then we have got where we get our 50% animals dying, where we get LD50, and that plateau where we have 100% kill. So this is a generalized dose response curve which has got 3 distinct areas. The first area where you have 0, no detectable response, and you have an increasing linear response where we get our 50% killing, therefore reducing our LD50. And the plateau, the maximum response, that is where we get 100% death rate. The lowest dose that produces measurable response is known as our threshold. These are the type of graphs which are obtained by doing these evaluations. So the first graph more or less shows what we're seeing in the first graph. But if we convert the percentage to a probit and the dosage to a log, we get a straight line, as indicated by those by the last graph. So log concentration versus probits, you get a linear, and you can get an equation which we can use to estimate probably to get our LD50. Now, when we conduct these studies, in order to get an idea of how toxic a pesticide can be, there are certain factors which can affect the response we get. Although we get a group of animals, number one, age can affect our results. We may end up saying the product is not toxic, yet it is very toxic. The reason could be we have used old insects which can tolerate the pesticide. So we tend to underestimate the toxicity. It could be related to sex. There are female insects which are more tolerant compared to male insects. So if your population consisted of females, then you can also underestimate this LD50. The rearing temperature can also influence the ability of the test animals to tolerate the pesticide. Food supply, the feed can also influence tolerance. Population density, overcrowding of insects can induce lower tolerance, and we may end up overestimating the LD50. Light illumination can affect also the activity of many insects, and this could interact with the concentration and influence our results. So, although it may be difficult to come up with the LD50s, but at least we have guidelines which can give us an indication of how toxic a pesticide is, and we can take precautions to protect those who are using the pesticides. So this is it on the evaluation of pesticides for their toxicity. We have to stop recording, then